let's do section 8 on magnetic force on moving charges. A particle of charge Q equals minus 9.7 microcoulombs has a speed of 850 meters per second. The particle lies in the xy plane and travels at an angle of 53 degrees with respect to the x-axis. There is a uniform magnetic field of magnitude 1.2 Tesla parallel to the y-axis. What are the magnitude and direction of the magnetic force on the particle? So I'm going to go ahead and start drawing some pictures. So here is my three-dimensional Cartesian grid. So I've got X, Y, and Z. Okay, so I'm told my magnetic field is parallel to the y-axis. So here it is. So there's B. Now my velocity is at an angle of 53 degrees to the x-axis. So it's something like this. Okay, so there's my V, 53 degrees with respect to the x-axis. Okay, now we have to figure out the magnitude and direction of the magnetic force. Now, the magnitude of the magnetic force is always going to come from this formula, QVB sine theta, right? You just plug in the amounts. The direction is going to come from the right-hand rule, which we'll do in a moment. Okay, so Q is negative 9.7 microcoulombs. You don't put the negative in this formula because you don't want to get a negative force out. You will figure out the direction yourself using the right-hand rule. So for here, just put the magnitude. 9.7 times 10 to the minus 6 coulombs, because micro means times 10 to the minus 6. V is 850 meters per second. B, 1.2 Tesla. And my angle, sine of theta. Well, remember theta is the angle between the velocity and magnetic field, right? Now, in the picture, 53 is the angle between X and V. I want the other angle. I want this angle in here. So this angle is simply 90 minus 53, right? Because this whole thing is a 90-degree angle. So 90 minus 53 is 37. So therefore, I'm going to multiply this by the sine of 37 degrees. Okay, so all you have to do is punch those numbers in your calculator, and you're going to get a magnetic force. So here's the magnitude for now of 5.95 times 10 to the minus 3 newtons. Okay, so far so good. Now how do we find the direction? Like I said, we got to use right-hand rule. Now here's the thing. I can use my right hand, right? So there's two ways I can do this. I'm going to show you with my right hand first. I'm just going to see if I can lift this a bit so you can see a bit easier. Okay, there we go. So here's my right hand. Okay, so remember the idea is this. If I have, so let me turn this a bit so you can see what's going on here. I stick my fingers in the direction of the velocity, and I have to curl it towards the direction of the magnetic field, right? Now remember, even though the way I'm doing this now looks like my thumb's coming out of the page, remember that these two forces are in the XY plane. Okay, so just imagine being in the XY plane. You're in the XY plane, you're pointing towards the velocity, you're angling towards magnetic field. So if this sheet is my XY plane, then coming up from the XY plane is the Z axis, specifically the positive Z axis. Now here's the thing. Because it's a negative particle, it's negative 9.7 microcoulombs, you can think of it as this. If I use the right-hand rule and my thumb points up in the positive Z, therefore for a negative particle, it would point in the negative Z direction. Or you can see it like this. I personally like this a lot better because I don't have to keep making negatives. I say, you know what, if it's a negative particle, I use my left hand. Okay, so here's my left hand. So my fingers, same thing, are going to curl from the first vector to the second vector, and my thumb points in the direction of the last vector, which is F. So notice if I go F cross B, where's my thumb pointing? Down into the page, which is the direction of the magnetic force. So it's going into the negative Z axis. So up to you, whichever way works better for you, that makes sense to you, use that method. But overall, make sure you get to the same destination. So our magnetic force is 5.95 times 10 to the minus 3 newtons in the negative Z direction. And that's it, guys, for the video. I hope you enjoyed it. If you did, be sure to smash that like button and stay tuned for future videos. I'll be posting the next one, 180, Magnetic Force on Moving Charges 9. So stay tuned.